Hello, everybody. This is Monica Paolini, and today with me, I have the pleasure of talking to David Soldani. He is the SVP of Innovation and Advanced Research at Rakuten Mobile. David, thanks for being with us today.
Thank you for having me.
So 6G is a huge topic these days, right? Because there's so much anticipation, and but at the same time, people feel like we're still in the middle of 5G. So why are we talking about 6G? And so let's just get started first. Why don't you tell us what is your involvement with 6G, and then let's see what is 6G and how we're going to get there. So what are you working on 6G? What's your role in that?
So I've initially served as Chief Information and Security Officer for Rakuten Symphony, and then it's now more than a year that I am leading the Next Generation and Advanced Research Business Unit at Rakuten Mobile. So we are responsible of bringing innovation into the Rakuten mobile network, which I think is one of the most advanced disaggregated and virtualized system in the world. So my business unit aims at taking that forward in various terms, in terms of architecture design, but we are also studying a new fundamental enabling and technology, particularly our focus is on cloud native architectures and technologies such as the extended version of the Berkeley packet filter. Now, what I think of 6G, if that is the question, I think the 6G or next generation of ubiquitous mobile communication systems aim at realizing the paradigm shift from the Internet of Things to the Internet of Intelligence. And I define intelligence, any function you may implement that as you please. It could be software, hardware, that has ability to acquire knowledge, process knowledge, and make decisions. So having this vision in mind, I think there are new capabilities coming into the system, and by the way, recently formalized into the papers we have received from the ITR that is about the vision and capability of the IMT 2030. And so what 5G aims at is first is to practically extend the existing capability of 5G, 5G Advanced. You may think of hyper reliable and low latency services. You may think of immersive communication, which takes you beyond extending, so beyond the EMBB. And then it extends the massive communications. So the aim is to integrate even more devices per square kilometer or per square meter. But what it introduces new are basically, number one, ability of having integrated AI and communication. Number two is about the integrated sensing and communication. And finally, what we aim is at ubiquitous connectivity. And here I think with the integration of non-terrestrial networks, particularly low Earth orbiting, LEO satellites.
Now, you put so much content into 1 minute that let's try to unpack it a little bit, one step at a time. This is all very fascinating. Now, the first thing is that you put it in the context of 5G, and I think that what people really are sort of wondering is, how do we get from 5G to 6G? Meaning, is it a step function that one day 6G will appear, or is it more of a continuous growth? Because especially as as the evolution of technology becomes more software-based, the idea that we're going to wake up one morning and everything is going to be 6G just doesn't sound quite right. it seems like it's going to be more of an evolution. How do you see that? How is this evolution, and what are the steps towards 6G?
It's definitely an evolution and not a revolution. And that has already started with the 5G advanced and related features and enhancement in terms even of architecture design. So if you think of 5G advanced comes with three fundamental enhancements. So we have an enhancement in terms of experience and user experience with the support of XR and guaranteed quality of service end-to-end. It also enhances coverage extension. You may think of uplink enhancement, so the mobile phone ability to reach the network. And then you may think of the massive introduction of non-terrestrial networks, satellites, which is release 17 already specified, but also data releases going up into the support of spectrum. And then I would say fundamentally introduces excellence in operations. And here we have AI and machine learning that comes along with the capability of supporting load balancing, mobility positioning, and also we have algorithm now for enhancing the performance and to end of the system, but also energy consumption. So I think that the 6G journey has already started. And then what's coming next is the introduction of new capabilities that, as I said, will allow us gradually to support the three new users scenarios I mentioned earlier.
Absolutely.
So practically we will assist an evolution that will come with enhancing the 9 earlier capability of the system, plus introduce the 6 new capabilities as I have mentioned earlier.
Yeah, and so what it sounds like is going to be a much more complex type of network. So the complexity is going to increase along with the intelligence. So let's get the two together. Let's talk about the intelligence first and the complexity next, because then how do we manage the complexity? But it's going to be, I guess that right now AI is sort of an add-on. You introduce AI wherever you can, but 6G is going to be fundamentally driven by AI. AI is going to be at the sort of the center of it, right? So how is that AI going to change with 6G? Is that going to be a different way to use AI?
So also the AI, what we're having today, what we assist today is a system that is AI enhanced, what we say, in the literature, but also within the industry and academic world, to something that is AI native. AI native means that the system is designed in a way to accommodate artificial intelligence. I'm particularly mindful and thinking of machine learning into the various aspects. I may think of reinforcement learning, be there, say, for optimizing certain type of functionalities, such as radio resource management, beamforming. You may think of unsupervised learning that will allow us to achieve an easy way of clustering certain type of informations, and therefore act even in real time, like detection of anomalies in the system without human intervention, or bring that capabilities to achieve much better security in the network. And then, of course, we have the supervised learning, which is the dominating technologies. And here we are thinking of a system that we support those algorithms that will allow us to, for example, improve channel estimation. We are now thinking of combining the channel coding and source coding at the same time But I also think that AI will allow us to have a much more efficient way of transmitting data between the 2 points. So that's necessary, because if you think of having a system that integrates sensing with communication, sensing at let's say 300 gigahertz or very high frequencies, sub-terahertz, it will incorporate massive amount of data. So we need to find a way, okay, we could enhance, say, the transmission like quantum key distribution, but I think fundamentally we need to reuse the existing infrastructure. Therefore, we need to achieve a sort of semantic communications between the 2 points. So we don't need to transmit bit and bytes that basically we are already on top of the channel capacity, but we can think of other means and method that by exchanging less information with the GTP, I definitely believe that we could detect and reconstruct the information much more efficiently, and therefore save channel capacities, basically the capacity between the 2 points.
So basically, this is a way to, well, AI, I guess, AI, ML, automation, and basically it's a new approach to managing the network that is more efficient, which is, you need to be more efficient if the complexity goes up. Otherwise, you're going to be the victim of complexity.
Yes,
right,
absolutely. So, and also there will be, I think, a massive introduction of generative AI. Although I think most of the advancements will be on the classical, say, machine learning. Little more will be done on the reinforcement learning due to the complexity, but generative AI will play a key role into any business process, so that we have an easy way to prompt, through prompting, to exchange information between humans and the system, and therefore alleviate the human intervention and complexities into a number of business processes.
Yeah, and I guess that, you know, when you think about AI and ML, they're just going to be working and helping us at different levels. It's not just one thing that they're going to do. Now, another topic is that as we move forward, now it's not just a 6G thing, but we get to rely more and more on connectivity. Not just at the personal level, but in terms of our economic processes, production processes, and, you know, anything, just monitoring the environment. And so we need networks that are more reliable. But reliability traditionally has come at a cost, because that's, you know, you achieve it in order to achieve it. How do you see the evolution of reliability to go with 6G? Is it going to be the same thing? Is it going to change?
Yeah, so reliability, or the availability of the system in general, how the connection or the service is reliable, and it is particularly achieved by redundancy. So we need to duplicate whatever it is, a packet or it is a software component or a hardware component, and that is definitely something we need to improve. Because if you think of communication networks today, or networks in general, that introduces massive costs and waste of resources that are not currently exposed. So what I'm thinking of here is that the architecture itself, and then the 6G, or the evolution of 5G, needs to come along with a reliability component as a requirement that needs to be achieved by design. So we need to revisit how we have been designing the network and introduce the meter requirements from the very beginning. And at the same time, we need to have ability to expose resources and network capabilities we are not having today. Like today, beyond connectivity, we could, at the same time, expose resources like CPU utilization, memory, storage, not used to the consumer itself, but also enterprises, and then release them in the case, say, something that happened to the network with a higher priority to avoid incidents of major harm or network impact like we have seen here in Australia, for example.
Yes. Now let's talk a little bit about how we're going to use this 6G networks. And there has been a lot of talk about the metaverse, obviously, but I would say more generally immersive type of experiences. Are those driving the need for 6G, or is 6G enabling them? I mean, what is, and how important are they going to be to the success or even a deployment of 6G? Are we going to start using connectivity in a completely different way, in a sort of more, I guess, immersive way?
Thinking of the immersive experiences was one of the requirements we set for 5G back, I think it was in 2014, 15, when we were thinking of the next generation system. And I also think that 5G and 5G Advanced in particular, they already meet those requirements, because also even the radio interface now has changed so that you can support the type of content between the mobile phones or the radiating elements in the uplink and the corresponding software hardware in the downlink. So I think that that's happening already and will be support nicely by 5G Advanced and its evolution. If you think, for example, one of the fundamental enabling technologies we brought in the picture a few years back was the Cloud X. So the thinking was, say, okay, we're having expensive devices, and is there any possibility of visualizing the rendering of the many applications, and think of even a transmission of the signal in the downlink, multiple views, just select the view that is in alignment with your parallax. So this is already there, that we have brought all those capabilities into the cloud and then offer that as a service to the end user on devices that are much cheaper. Now, the success of this particular use cases hasn't been really visible, also because we lack the support of latency. So if you look into the existing networks today, globally, I think it's very hard to go below the 20 milliseconds end-to-end, which is the minimal requirement if you think of a teleoperated driving, where you can use this kind of experience for providing tasks or work on machines remotely. So I think that is and will be supported by the existing capability once deployed and 5G Advanced. What I think we are expecting from 6G is to enhance other aspects of the network. One is, for example, positioning. If you think of positioning, it is an essential component, because if you want to connect a robot, you need to maneuver this robot with really the minimal distance. You cannot say stop robot, that keep going. It could be like harming or hurting. So positioning is, we are thinking, 1 to 10 centimeters definitely needs to be met. The interoperability also needs to be revisited. And here I think of a communication system in its standalone configuration, which has ability to have open interfaces, and the O-RAN and the NGRG within the O-RAN Alliance are definitely going into this direction. Has to be a sustainable system. So there are many other new requirements, I think, far beyond enhancing the end user end user experience. And sensing, for example, it is crucial, because if you're having ability to transmit and receive at very high frequencies, your radiating point, you may think in the downlink, so the base station, but also in the mobile phone, the system has a sort of eyes. This information, it can be used not only to improve the performance of the network, but also to generate plenty of new services. And then I think we need to achieve coverage. So I think the 6G needs to take us to a level where we resolve this problem hanging there now for 20, 30 years or even more.
Absolutely. Our time is up, and we could be talking for a long time. It's always great talking to you, but let me ask you I want to have a very quick answer to this. What is the thing that fascinates you the most, that you have more anticipation for in 6G? If there is only one thing, what would that be?
Yeah, so I'm not sure I'm introducing here anything new as a result of the fact that when we envision 5G, we had in mind many use cases, and only a few really are now currently supported. But there is one particular scenario or use case really dear to me, and that is the connected intelligence. And here I am really mindful of connecting service robots. So if we achieve a robot that's not so expensive, that is about mainly the mechanics around it, then the crucial point would be to remove the cable to the robot, right? Robot of any kind, you may think of a humanoid, you may think of a small car, it could be anything. So that is the use case, which is, I think, 6G will allow us to achieve. And in order to do so, the system needs to meet special requirements. One is reliability, so we can't miss the communication to that particular robotic platform. And then the second one is the latency. And latency is something we can improve, particularly leveraging the virtualization aspect of our system, where we can orchestrate and move certain cloud-native function as close as possible to the edge of the network, and therefore achieve latency, achieve reliability, because we could have an easy way of introducing redundancy to that communication, and finally, ultimately, support a service robot, wireless robotic platform, even could be offered as a service. And then the system should allow us to exchange those capabilities. You may think of a beyond metaverse, like think of those robotic platforms where they are exchanging what they learn in the cloud, that they don't need to spend much time into understanding that is a chair. I mean, they could retrieve the identity of that object and then find in the cloud the corresponding libraries and the knowledge that is exchanged, and create this kind of community, which to me is the shift from Web 1.0 to 2.0, and then maybe 3.0 to the community of intelligence objects, where also generative AI will play a fundamental role. And the 6G is expected to enable those capabilities.
David, thank you so much for sharing your thoughts, as always, inspiring. And thank you all in the audience for listening to us.
Thank you so much.